Okay, here is another quick update on the circuit I'm trying to make to interface the VFD with the Mikini. So what I've been trying to do is take the 1024 pulse per revolution encoder that's on the motor currently, on the AC motor, and make that into a 6 pulse per revolution in order for the Mikini to register an accurate RPM. So the way I've done that is I got a 74HC590 binary counter, which basically counts up to a certain number depending on the number of bits you get for the chip. So this chip ended up being an 8-bit chip, so it can count up to the number 255. So this is a representation of the chip. It has 8 output pins for 8 bits, and each one is going to be either high or low depending on what the number is. So for the number 171, the high-low ends up being 10101011. So what I can do is run each one of these outputs through various logic gates, in this case some AND gates, and then actually combine these two NOR gates into one to save a chip, and back through another AND gate, and then I forgot to put this in the schematic, but I ran this through another NOR gate in order to get the signal appropriate to reset the counter. So what this means is, lost focus there. What this means is the chip will count up from 0 until it reaches the number 171, or this code here, and then it will kick out a 5-volt signal to the Mikini, and also in turn kick that signal back to reset the counter. So it'll count to 171, signal, reset, and then start over again. And the reason I chose 171 is 1024 divided by 6 is roughly 171. So for every 1024 inputs into the chip, I should get 6 outputs. These are some other, this is the other logic. This is how I inverted the PWM. The PWM, or pin 7, comes into one pin of a NOR gate, and then pin 2 comes into the other pin of a NOR gate. Pin 2 will enable the PWM to go through the NOR gate, and at the same time it inverts the signal. Pin 3, the forward and reverse, also if you run both of those through a NOR gate, they'll be inverted, kind of acting as a NOT gate. So here is the circuit I made, pretty much completed, except I don't have pin 2, the PWM from pin 7 or pin 3 wired in yet, but that's very simple. It's just going to be wired into the NOT gate on this side. This is a NOT gate. These two chips are AND gates, and this one is my binary counter. And I don't know if you can see it, but this is the 8-bit sequence, and currently it's on number 171, or 10101011. And over here, this is active. This represents the pulses coming off of the chip going to the Mikini. Okay, and here's the chip in action. Here's the motor. I put a little piece of tape on there so you can see the rotation. See if I can get them both in the shot at the same time. So, there we go. So as I start to rotate, you can see the LEDs light up, representing the binary number. Then when it gets to 171, it will reset, and this light will pulse, like you just saw. Now I'll just go ahead and just kind of spin it at normal speed, and if you count the pulses, it'll actually pulse exactly 6 times per revolution. I don't know if that flash will let you see that or not, but it doesn't look like that. Pulse happens pretty quick. But anyway, that's how I converted my 1024 pulse per revolution into a 6 pulse per revolution signal for the Mikini.